Why should we be interested in Euclidean geometry? Probably because it is the branch of mathematics which introduced some standards of rigor to mathematical thinking, standards of logic, of building a proof. Euclidean geometry is the first branch of mathematics to apply axiomatic approach. So it starts with postulates. There are three foundational ones, and we won't go further because these three will enable us to make straightedge and compass constructions. These postulates are: 1. Through any 2 points a straight line can be drawn. Through any 2 points a straight line can be drawn. So what do? We choose a couple of points first. Let's call them A, B, now we use a straight edge and join these points with a line. We can call this line L, and the segment we call segment AB. The second axiom is pretty obvious too. It says that any straight line, let's write it down, 2. Any straight line can be extended arbitrarily far. Extended arbitrarily far. So we can do it with our line L. We can fit the straight edge again to match the line. We can extend it on both sides. Of course, we only have this sheet of paper here, but we can imagine that we can go further and further both sides. We can go on and on. And of course we can follow the same procedure with any 2 points. So let us mark another couple of points. Let them be point C and point D, and let us draw a line between them. So we will have a segment C D, and of course we can extend the line on both ends, on both sides. You can call it M. Now the third axiom says something about circles. If we are given, all right, so let's write it down. Axiom 3, given a point and a segment of a straight line, a circle can be drawn with its center at a given point and a radius which length of the radius equals to the length of the given segment. So let's make this simple construction. Let's choose our center first. Let it be point O, and we'll need a couple more points. Let's call them E and F, and we'll need a segment of a straight line between them. And now with this radius, of course, we've got to use our compass now. We need to set the spread of the legs of the compass to the length of the segment, and with this radius we need to draw a circle now. Here we've got our circle with center O and radius. Let's mark it any of the radii. So let's mark this one, let's call it R. Let's mark the length of the segment EF as F, and by construction these lengths, the radius and the length F of the segment EF, are equal. These simple axioms will let us construct many intricate objects and solve many arithmetical problems. Now we can show the same axioms of geometry by means of a computer program. Elementary Euclidean geometry, straightedge and compass constructions. Straightedge and compass constructions assume three postulates about the geometry of the surface on which they are performed. The postulates are called Euclid axioms, and they are: a segment of a line can be drawn between any 2 points. A segment of a line can be extended arbitrarily far in both directions. Given a segment of a straight line and a point, a circle can be drawn with center in the given point and radius equal to the length of the given segment. Euclid himself was aware that the actual constructions take place on the surface of the Earth, that is, on a sphere. It is only on small patches of this spherical surface where the Euclidean geometry is a good approximation of reality. Surprisingly though, Euclidean geometry is a very good approximation of reality in astronomy. So, a segment of a line can be drawn between any 2 points. This segment can be extended in both directions, and if we are given a point, which will be the center of a circle, and a segment, and the length of this segment will make a radius of the circle, then we can draw such a circle. For this, we only need 2 things: a straight edge and a compass. A straight line can be drawn between any 2 points. That's the postulate 1, or axiom 1. Here we got it. A straight line is being drawn in between points A and B. And we can repeat this process as many times as you like, between any 2 points. Just a side remark, these are random points within the frame of the screen. Because of course I could have programmed it to make points anywhere within the scope of the program, because program has limited space as well. But we want to see the points. Let's try again. So again, we've got point A, point B, and a line is being drawn from A to B. Now we will try what it is with the extensions. Postulate 2. Any segment of a straight line can be extended arbitrarily far from any side. So we've got again segment AB, we extended it, and now we've got 2 rays going to infinity. Well, that's how we like to think about it. So now postulate 3. Let a point and a segment of a straight line be given. Then circle can be drawn with center at this point and the radius equal to the length of the segment. So we are transporting the length of the segment to the center, O, and drawing kind of like with a compass. And voila, we've got the circle. There is a relation between Euclidean geometry and arithmetic, namely, geometry satisfying the first 3 axioms of Euclid is equivalent to elementary arithmetic. It also allows all the straight edge and compass constructions, and through these constructions we can add segments, we can subtract segments, we can multiply them, say by building rectangles, we can divide segments, and we can make plenty of different constructions. As far as the axioms are concerned, it is a bit complicated. In the 20th century, there was a thorough research into axiomatic systems, and first David Hilbert and then Alfred Tarski made new complete systems of plane geometry. These are more involved. They have, as far as I remember, 20 axioms. But we don't need to care about it. We can deal with these 3 axioms, plane geometry, and it will be just fine for us.